Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fourth question from the mid-year examination which was written in the province of MPUMALANGA. Please guys, do expect a total number of 8 videos since the question paper had 8 questions in total, and that simply means each and every question will have its own video. And please guys, do take this seriously, because knowing how to tackle exam questions, I strongly believe it will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, please do subscribe to our channel just to help us grow. Please. Okay. The sketch below represents the graphs of f of x and g of x. The point A, there's point A over there, is where the asymptotes of f of x intersect, and then the graph of f intersects the x-axis at that point over there when x is equal to -1. Okay, now they want us to write down, or before we answer the questions, now guys, before I answer the questions, my graph of f of x should be in this form. I don't know the value of a, but since I do know the point of intersection of my asymptotes, the x value is -3. That means I must write +3 over there. Are you together? When this guy over here is negative, that means at the bottom I should have plus. And then for the y value, I must just leave it as it is. So I'll simply say +2. Are you together? The only thing I need to do is to just find the value of a. And whenever I calculate the value of a, guys, I should get an answer which is negative. Why is that the case? Because my graph is on the second rather and fourth quadrant of my asymptotes. If that's the case, it simply means that a should be less than 0. And for me to calculate to a, I just need to find a point on the graph and then just substitute that point. Excuse me. For example, I can simply substitute this x-intercept over there. Y is 0 whenever x is -1, and then I will only be left with I'll only be left with a as the only unknown variable, and then I'll simply solve for a. Né? But okay, let's answer these questions. Let's answer them questions. Write down the equation of the asymptotes of f of x. X is equal to -3. That's my vertical asymptote. And then for my horizontal asymptotes, y is equal to 2. Okay, and then I must write down the coordinates of the y-intercept of g. The coordinates of the y-intercept of g, I can see that the graph of g, guys, simply cuts the y-axis over here, and over there, guys, I do have a horizontal line, whereas its y value does not change. So on this horizontal line, y is equal to 2 on that horizontal line. So that simply means that the coordinates of my y-intercept, x is 0 always the time on the y-axis, but y is equal to 2. Y is equal to 2. Since I'm given the equation as well, guys, I could have simply solved for my y-intercept. I know that for my y-intercept, I don't care what kind of a graph I'm dealing with, but I always know that x is always equal to 0. So 2 to the power 0 plus 1, this will just give me 2. So I now know that when x is 0 on the graph of g, its corresponding y value has to be 2. So that's how I was supposed to deal with that question over there. Then now I'm supposed to determine the equation of f of x. Basically, I must find the numerical values for both, for rather a, p, and q. Né? Excuse me. F of x is equal to a, x plus p, and then I simply have plus q over there. I have a. So these two guys, they represent my asymptote, right? So this one is for my vertical asymptote, and the other one is for my horizontal asymptote. Né? Since my x is negative, that means I must write +3 over there. But for y, I must just keep it as it is. So it's just +2. So there's f of x. The only unknown variable I have is a. For me to find the value of a, I must find an extra point on the graph. I do have an extra point, which is the x-intercept. I know that y is 0 if and only if x is equal to -1. But remember, I had plus 3 and a plus 2 over there, né? And then whenever I take the 2 to the other side, it will be negative, so I'll be left with -2 is equal to a all over 2. Therefore, a is basically equal to -4. And yes, guys, I'm supposed to find a negative answer since my hyperbola is on the second and fourth quadrant of my asymptotes. So since a is equal to -4, therefore f of x is just -4 x plus 3 plus 2. This is my function. So f of x is just -4 over x plus 3 plus 2. Okay, now I must write the equation of the axis of symmetry of f in the form of y is equal to mx plus c with a negative gradient. For my axis of symmetry, guys, my equations for my axis of symmetry, the first one will be like this. It will have a gradient of 1, and then the other one which is a decreasing function has a gradient which is just equal to -1. So they did specify that which line I'm supposed to write the equation of. Né? They said the one that has a negative gradient. Less than 0 simply means negative. So I know that y is equal to mx plus c, right? But y is equal to -x plus c. Remember, the gradient is -1. So all I have to do is to find the value of c. I just need to substitute the point. I can simply take the point A, which is the point of intersection of my asymptotes. I know that y is 2, and if and only if the corresponding y value is -3. So therefore, the value of c, this will simply give me 2 minus 3, that's -1. So therefore, the equation is basically -x minus 1, since the constant is -1. So this is my equation. Okay, now I'm supposed to write down the domain of 4 times f, and then of this newly transformed equation rather. So the transformation that took place, the function was enlarged by 4 units by a scale factor of 4. And then the function was shifted 2 units to the right altogether. So initially, guys, my domain for this original graph, the domain for this original graph, I can see that my graph exists anywhere on x, everywhere except when x is equal to -3. So the domain of f of x, I can simply say x is an element of real numbers, but x cannot be equal to -3. If ever, guys, I'm shifting my graph 2 units to the right, that means the domain should shift 2 units to the right as well. So the new domain, the domain of 4 times f of x minus 2 is basically x is an element of real numbers, but x cannot be equal to -1 because I've shifted my domain 2 units to the right. Altogether, x is an element of real numbers, however, x cannot be equal to -1. Okay, write down the equation of h. Excuse me. Write down the equation of h. If h is the graph, if h is the graph of g, that is translated 1 unit down. Okay, the graph of g, guys, was given to us. G of x was given to us as 2 to the power x plus 1. Ne? But they are telling us that for us to find h of x, we must just translate to g of x 1 unit down. That means I must say g of x minus 1. Are you together? So whenever I do that, I'll simply get 2 to the power x plus 1, and there's this minus 1 from the transformation. And then the final answer will simply be 2 to the power x, because these ones will just subtract one another. So h of x is basically 2 to the power x. Okay, and then they want me to determine the inverse of h. Remember that, guys, for me to find inverse, since I know that my graph is 2 to the power x, for me to find inverse, I must always reflect my graph on the line y is equal to x, and then that means I must just interchange both x and y. I'll simply have x on the left hand side and 2 to the power y. If I have this scenario over here, guys, yes, I can introduce logs on both sides. Okay, let me just do it step by step, even though it's 1 mark, so that you will know where it comes from. You'll introduce logs on both sides, log 2 base y, and then there's log again. There's a rule that says in logarithms, guys, you can make your exponent of your index to be your coefficient. So y, since it's the exponent of my index, is now my coefficient. This is log 2. I can divide both sides by log 2, therefore y will simply be log x all over the log of 2, then y is basically log x base 2. After doing this, guys, you can just go straight here. Your graph will always be like that. This base over here will simply be the base over there, and then the x will simply be the index of our logarithm. Are you together? You can just go straight here, move from here to there, because it's just 2 marks. They are marking you for for this statement over here, and that's one over there. Okay, now they want us to find the range of h of x. The range of h of x, guys, remember that, guys, you can draw your graph so that you can see your range. However, please do note that the domain of your original graph, which was h of x, will be the range of the inverse graph. Why? Because whatever that happens on the x value on the original graph will happen on the y value on the inverse graph. Are you together? Since we had this, since our graph was just going to be like this, that means its domain was just going to be x as an element of real numbers. Are you together? Therefore, I can simply say that the range of my inverse will simply be y is an element of real numbers. Are you together? But if you don't want to check it, maybe through the original graph, you can simply draw your inverse graph. It will just look like this. You'll simply have your y-intercept there. Maybe you can have your extra point. Probably when x is 2, y is 1. You can draw your graph like this. There's nothing wrong. You can see that, guys, according to y, your graph moves from negative infinity to positive infinity. That's why I simply said y is an element of real numbers. Are you together? Please note that the range of the domain of your original graph should always be the range of your inverse graph, and your range of your original graph is always your domain of your inverse graph. Okay, so our range, I'll simply say y is an element of real numbers, and then for which values of x, if f of x and the derivative of g are less than 0. Okay, let's go and analyze over there. F of x and the derivative of g are less than 0. We are multiplying two things and the answer is negative. Okay, first things first, guys, my graph for g of x is forever increasing. Are you together? My graph for g of x is forever increasing. Are you together? So it always whenever I can draw a tangent on this curve of f of x, it will always have a positive gradient. It will always have a positive gradient. Okay, I'm multiplying f of x and g prime of x, and I'm getting a negative answer. I've already established that this guy should always be positive because the graph is forever increasing. Né? The derivative, guys, g prime of x is just a gradient of a tangent at a specific point. So this, if my g of x if my g prime of x rather is always positive, it simply means that I simply have an increasing function. Are you together? So since my graph is always increasing, that means g prime of x will always be positive. So for me to multiply this positive number and get an answer which is negative, that means f of x should be negative. Are you together? And f of x is only negative if and only if it is below the x-axis. Are you together? So this is the only region where I can see g prime of x positive and f of x negative whenever f of x is below the x-axis. This is the only region. Are you together? So I'll simply say when x is between -3, which is the asymptote, and -1, which is that x-intercept. Because after the x-intercept, f of x will now become positive. Are you together? So this statement is true only whenever x is between -3 and -1. This is true when x is between -3 and -1. Okay, I did not see what that this thing was included. Ne? There was an equal sign over there. That means we must include -1 as well. Please, guys, do not include -3. Why? Because -3 is an asymptote. Are you together? One of the graphs is not real whenever x is equal to -3. So you'll only include -1 over there. That's how, guys, you should express your answer. Yeah, so please, guys, do stay tuned and wait for more videos. Thank you.